All right, we're now ready to put together all the stuff that we've learned about angles and their relationships and stuff like that. So as the warm-up, I've got a quick review of this vocabulary that we've been talking about. But again, the I can statement here is I can use angle relationships to solve equations. So we're going to be writing some equations from the information that we know about these particular types of angles. So don't forget that. It's not just enough to write down your answer to the problem because oh, I know what the answer is. You need to write down an equation. That's what we're focusing on here. So it says define the following. So adjacent angles, those are angles that are right next to each other. So here's what I'm going to do. Angles that are right next to each other. And remember, they share a side. That's how we can really tell that they're adjacent to each other. Now, there's nothing terribly special about adjacent angles unless there's some other information that we can see from the diagram or that are told. Okay, but again, notice that I use that little angle mark just to save a little time in writing the word angle. Vertical angles are opposite angles. So I'm going to use that angle symbol with an apostrophe S. And they are formed by two intersecting lines. Two intersecting lines. All right. And remember, vertical angles, they're always congruent. They're always equal to each other in size. Okay. Complementary angles, two angles that add to 90 degrees, shorten that just a little bit, okay? And supplementary, two angles that add to 180 degrees. Now, linear pair, we talked about that at the end of the last section. What we could say here is another name for supplementary. Another name for supplementary. So remember, they called them supplementary angles because they added up to 180 degrees, and 180 degrees makes a straight line. So if the two angles make a straight line, we can just call them a linear pair. So that'll come up occasionally. So just make sure that if you see the word linear pair, just say, oh, they're adding up to 180 degrees. That's just as if they were supplementary, because that's what they are. Okay, now we've only got a couple problems that we're going to take a look here, and please make sure you're following the instructions. It says we can use angle relationships and equations to find missing information in a diagram of angles. So we've got a couple diagrams right here. Now you want to make sure that you're paying attention to all the instructions. So here are the instructions. Name the most specific relationship between the angles, because some of them it could be more than one. Write an equation that represents the angles, then solve for x. So we've got to write the name of the most specific angle, we've got to do an equation, and then we've got to figure out what x is. So we've got to do those three things on each one of them. Now, what we notice about this one right here, again, some extra lines and a bunch of stuff floating around here, is this. This is a straight line. If that's a straight line, those add up to 180 degrees. Those two angles right there would make 180 degrees. Well, if they add up to 180 degrees, the most specific name we could give to that is supplementary. So we got that part taken care of. Next, we need an equation, and the equation would be that we're going to take that 3x plus 18 plus 93. So we're going to take the one angle and the other angle, and we're going to add those together, and it should equal 180 degrees because that's what supplementary means. So we've got the name, we've got the equation. Now we want to go through and we want to solve this. So if we solve this, we get 3x. If we add the two of those together, we get, let's see, we get 111 equals 180. I'm going to subtract the 111 from both sides, so we get 3x equals, and let's see if I do 111 or 180 minus 111, that's going to be 69. We're going to divide by 3, so we get x equals 23. Now, x on this one, you don't have to put a degree symbol because the degree symbol's actually outside. We just want to find the value of x. Okay? So we've got that right there. So we named it, most specific name we could. We came up with an equation and we solved for x. We're done. Okay? So we named it. There's the equation and there's the answer. So that's what we're looking for in each one of these. Now let's take a look at this next one right here. again, got lots of lines and angles and everything floating around. We want to take a look at the two of these because those are the ones that we have information on. Straight line here, straight line here. So it's almost as if this one doesn't exist for the two angles that we're interested in. Those are made by intersecting lines. They're opposite from each other, so those are vertical angles. So I'm going to write vert right there. Okay, so we've got the name of the angles. Now we're going to write down the equation. Remember, vertical angles are congruent to each other. They're equal to each other. So there's the equation, and then I'm going to solve the equation. I'm going to subtract 2. We get 3x equals 60. We're going to divide by 3, and we get x equals 20. Again, I don't need the degree sign because the degree sign is already on the outside of that little expression that represents the measure of the angle. Now, I do have a thought question for you. We haven't done anything wrong. This is totally okay. We've done everything just right, followed the instructions and everything. But how could we make sure that we have the answer right? Let's say these were test questions. We had 5 extra minutes or 10 extra minutes the day of the test, and we wanted to make sure that we had these right. Is there a way where we can say, you know what? I don't just think I did it right. I know for absolute fact that I got this right. Well, one thing we could do, and you may have thought about this, is plug x in. If you plug x in and it works out, then you're in good shape. So I'm going to come over here and I'm going to take this, and I'm going to do this in blue, and I'm going to plug it in right there. So here's what this means. This is 3 times, we're plugging in 23, so 23 plus 18. So 3 times 23, let's see, 3 times 23 is 69. 69 plus 18. Well, let's see, if we were just adding 10, that would put it at 79. And then another 8. So that's going to put this at 87 degrees. So that's 87 degrees. We'll take a look at what happens. What happens if we take 87 degrees and this other one that we know is 93 degrees. So 87 degrees plus 93 degrees. If you add the two of those together, you do end up with, so this 7 right here would make that 100. So then we've got 100 here and 80 there, so we get 180 altogether, which is what we should have. Okay, so we know we got that one right, so we're in good shape there. Let's take a look at the next one. All right, same type of thing. We want to follow those instructions. We want to make sure that we're naming the relationship, most specific name that we could, write an equation, and then solve that equation. So what we want to look at here is that's 90 degrees and this is a straight line. So what that means is that's 90 degrees. So these two angles right here make 90 degrees altogether. So that means they are complementary. And I'm going to put the E on the end of there just to remind us. So those are complementary. That means if you add the two of them together, 6x plus 2 plus 40, so there's one angle and there's the other angle, should equal 90 degrees altogether. Now, I do want to point out that if you were to write 40 plus 6x plus 2 and set that equal to 90, that's not wrong, but you'll notice that we have to collect these like terms and they're not next to each other. That's kind of why I wrote this one first, because that puts the 40 and the 2 right next to each other. So we get 6x plus 42 equals 90. We're going to subtract the 42, so that's going to be 6x equals, and let's see, 90 minus 42. 90 minus 42 is 48. Then we're going to divide both sides by 6, and we get x equals, let's see, 48 divided by 6 is 8. And there's the answer. So again, we've got the name, we've got the equation, and we've got the answer. We know what x is. Okay, so last one here. What name would we give for this one? Now, let's see. There are no intersecting lines, so we don't have any vertical. There are no marks about right angles. We don't have any that are straight lines going through and intersecting. We don't have 180 degrees anywhere. So this is the most specific name we can give to this. The most specific name we can give to this is that they are all 3 of them, they're all next to each other. They all share a side here, side there between the two of those, and then these two share that side right there. So the most specific name we can give is that they're adjacent. Now, adjacent is a great word to know, but really there's nothing too terribly specific unless we've got some other information. And the information that we have here is if you started right here and went all the way around would be 360 degrees. So whenever, and that's really the only thing that we're going to be able to use adjacent for. So when you write adjacent, Make sure that we can go around full circle and add all of those up, and then we're going to say adjacent add to 360 degrees. So I want that entire thing as you're going through there, because that's really about the usefulness of adjacent angles at this point. So we're going to leave it like that, and then we're going to write an equation. Now again, be smart about this. I'm going to write the x minus 24 first, then the plus 29, and then the plus 296. And if we add the three of those together, there's the first one, there's the second one, there's the third one. If we add the three of those together, we end up with 360 degrees altogether. So if I add those up, let's think about this. If I put the two of those together, that's going to be plus 5. And then if I add 5 to that one, this is going to be x plus 301 equals 360. So we end up with a pretty simple equation to solve. So we end up with x is equal to 59. Now again, because x is part of an expression up here, we don't need the degree symbol on there. We can just circle that and we're done. Okay, so there's our most specific name along with a description for adjacent. In this particular one, it adds up to 360 degrees. There's our equation, and then there's our answer there. Now let's take a quick look at two problems from the assignment. We're going to take a quick look at problem number 4 and number 18. Okay, I've got your worksheet up here, and I said we were going to take a look at problem number 4 and number 18. So let's take a look at number 4. Number 4 here, you'll notice we don't have anything like intersecting lines or anything like that. This is a lot like the one that we just got done doing. So you'll notice that they are all next to each other, and we can go all the way around full circles. So there's this big 298 degree angle right here. This one's 27, and then this one's the one with the variable. It's negative 14 plus x. So the name we're going to give to this is adjacent. And then again, we want to add some specifics to this, and that would be that they add to 360 degrees. Okay, so let's make sure we put that description right there. And then the equation, again, I'm going to write it down. Notice how the x is at the very end, so I'm going to do something kind of tricky. I'm going to do 298 plus 27 minus 14 plus x equals 360 degrees here. So there's one angle, there's another one, there's the third one. And then notice that I've put all of the like terms right next to each other. So we could quickly put those together. Those make 13. And then we can add 13 to this. That's 311. And then plus x equals 360. And then I'm going to let you finish solving it from there. It's a pretty easy problem to finish from there. And then let's take a look at number 18. So we'll flip it over on the other side, and here's number 18. Again, there are lots of other lines floating around here, but again, you're just focusing in on the angle. So we're really going to hone in on this angle right here and this angle right here. You can ignore all of this other stuff. We'll take a look at those. Even with the two triangles on each side and some extra lines and stuff like that, those are just made by two intersecting lines. So the best name for that is vertical. So we're going to set them equal to each other. So I'm going to take 3x plus 2, set it equal to 65, and then we're just going to go through and solve. That's basically it. So you should be in good shape.